All right, I want to do a couple more problems, actually a few more problems from the Section 9 homework for people to see. So whenever we have a problem and it says VL, so that would be this guy here, and VI, which is the whole thing, right? Starting off, what I like to do is I like to draw in my A's, right? We had that formula in the notes where we had the A's listed. You always have 2A coming out of the vertex, the angle here. And the other chunk is just a plain old A, right? There's all kinds of different ways we could say this. We could say that the longer piece is double the short piece. But in this case, I think it's easier to just leave it as the A's, right? We're not going to think about doubling or things like that. We're going to leave it as A's. The whole thing, we have A plus 2A, which is 3A, right? So the green, which is, what is the green piece here? Let me underline that. VI, and then the orange is the other one. So I could say, well, VL, that's the orange. It corresponds to the 2A, right? And then VI, well, that's the green. It's the whole thing. So that's 3A. All right. Now we're going to say, well, VL is also x minus 3. VI is also x plus 1. Now this is two equations and two unknowns, so we can solve this however we want. There's lots of different ways to do that. What I think is probably the easiest way to do this, the fastest way for me to do this, is to solve both of them for A. So A equals x minus 3 over 2, and A equals x plus 1 over 3. And the reason that I solve them both for A is just that whenever I look through these problems, this seems like the most consistently easy way to solve them, right? There are other ways to solve them, and if you have another way to solve it, that's great. Now, we have A equals A. So the left piece, I'm going to say, well, x minus 3 over 2 is equal to x plus 1 over 3. Now I need to solve this. This is just, we have our x's and we just solve. The easiest way for me at this point is to multiply both sides by 6. And why do I choose 6? Well, on the left side, my 6 and my 2 cancel to be a 3. And on the right side, my 3 and my 6 cancel to be a 2. So I got rid of my denominators there. On the left, I have 3 times the quantity x minus 3 is equal to 2 times the quantity x plus 1. Now I distribute. 3x minus 9 is 2x plus 2. I'm going to put my x's on the left, so I have a single x on the left, and 9, 10, 11 on the right. So x equals 11. The piece that I'm seeing people have trouble with is this labeling here at the beginning. Always try to do that labeling before anything else. Okay? This is only for the ones that actually are a part of the median. For the problems that deal with the sides here, you don't really need to use an A. But if it's going to be along the median, like if this is your median and it goes along it, the links that are there are on the median, you're going to need to use an A. Next up, LR is right here. RC is right here. Now there's two ways to approach this. In the last one, I just said that we need to use our A's. We can use A's here. We can say, well, this is 2A and this is A. The other way that we could approach this would be to say, well, the blue, what is that, LR, is 2 times RC. And that's the same thing we would do with the A's also, it's just written a little bit differently. I'm going to use the A's, that way we can be consistent. So the blue is 2A, so I'm going to say, well, LR is 2A. Well, 2A is also going to be 2x plus 12 fifths, right? Now for RC. RC is going to be equal to how many a's? That's just a single a, which is 6x minus 1 over 5. Now what I'm going to choose to do here is I'm going to take this a and plug it in to that a. Okay. If I had a 3 in front of this a down here, I'd have to solve for that. But in this case, it's already solved. It's already ready. We can just go about doing that. So I have my 2, and then I'm going to open big parentheses, and this is where I'm going to put in my yellow 6x minus 1 over 5. That's going to be equal to 2x plus 12 fifths. Now, think about this 2 in the front as a 2 over 1. You distribute your 2 to both of the top pieces. You distribute the 1 to the 5, which doesn't really do anything. So our top pieces becomes 12x minus 2 over 5. And then the right side didn't change. So 2x plus 12 fifths. Now we want to get rid of our fractions here. So the way I'm going to do that is I'm going to multiply the left side by 5 and the right side also by 5. And the reason I chose 5 is because all of our denominators are 5. Right? So on the left, this 5 and that 5 will cancel. On the right, this 5 distributes to the 2x to become a 10x. And then the other 5 cancels with that 5. So this will be plus 12. Solving gives me 2x is 14 and x is 7. So this one I did slightly different than the first one, and well, the problem was slightly different than the first one. This a was already there. You could just plug straight into the other one, right? Anytime there's a number in front of that, there might be the number 3 or the number 2 in front of it, I would want to divide and get my a by itself. Right? Just like up here, I divided by 2 and I divided by 3 there. All right, moving on. Find x if HD, well, that's the whole thing, is 2x minus 12, and BD is that piece there. So HD, how many A's does it span? Well, it's the whole length, so that's going to be 3A. Now for BD, well, now you need to remember, is this going to be 2A or 1A? The 2A always goes by the angles. This is 2A, this is A, which tells us that BD is just A. All right, now it's set up a whole lot like the last one. We have a single A, nothing in front of it. So I'm going to take this and I'm going to plug it into the other A. So this will be 3, parenthesis, x minus 7 equals 2x minus 12. So 3x minus, oh good grief, what is that? 14, 15, 16, 17, 18, 19, 20, 21. There it is. Is 2x minus 12. Whenever I subtract to the left, I get a single x. And whenever I add to the right, I'm not confident myself on that. I'm going to type that in. Negative 12 plus 21 gives me 9. There we are. So on all of these, if you get confused, write in your A's. Write in where should these single A and the 2A be. The 2A always, always, always touches the angle here. Always touches the angle. All right, that's all.